All right, we're going to look at the homework for Module 6, and this module has to do with the derivative rule. So specifically, we have the product rule, the quotient rule, and the chain rule. Okay, so the first one says, find f prime of x if f of x is 9x cubed times x squared minus 4. So we have a product of two functions here. And the thing is, we can't do the derivative just by doing the derivative of the first part times the derivative of the second one. So in other words, the answer is not going to be 27x squared times 2x, right? So notice answer A here is wrong. So how do we do the derivative? Well, we do the first function times the derivative of the second plus the second function times the derivative of the first, right? That's how you take the derivative of a product of functions. So notice we have the first function, 9x cubed, times the derivative of the second one, which would be 2x. So notice we have 9x cubed times 2x here and also here. But then we have plus the second function times the derivative of the first. And notice that's this one right here. We have the first function, 9x cubed, times the derivative of the second one, which would be 2x, plus the second function, x squared minus 4, times the derivative of the first. Okay, so it's not part C because it's supposed to be a plus, not a minus. Okay, that's the product rule for derivatives. Okay, this next one we have f of x is a product of two functions, x cubed times natural log of x, and we want to find the derivative. So notice our big function, our ultimate function, f, is a product of two simpler functions. So the way we take the derivative of f is to do the first function, x cubed, times the derivative of the second one, which would be 1 over x. So notice we're going to have an x cubed times 1 over x, so it's got to be one of these first, or one of these last two here, plus the second function, natural log of x, times the derivative of the first. So notice that's what we have here in answer C. The first function times the derivative of the second, derivative of natural log of x is 1 over x, plus the second function, natural log of x, times the derivative of the first one. Okay, now this one is not a multiple choice. It just says find the derivative of this. We have, again, a product of two functions, 2x to the fourth times natural log of x. All right, so how do we do the derivative? Well, f prime of x is going to be the first function, 2x to the fourth, times the derivative of this, the derivative of natural log of x is 1 over x, plus the second function, natural log of x, times the derivative of the first. And the derivative of 2x to the fourth would be 8x cubed. Now, it would be totally fine to write this in as your answer, and I think MyMathLab would mark this as correct, but we can simplify this. So for example, x to the fourth times 1 over x, that's really just x cubed. We get an x to cancel with this x. So this is really 2x cubed plus, and I like to write this part here, like a polynomial part before the ln of x. So let's write it as 8x cubed times ln of x. But again, MyMathLab should mark this as correct. But I'm going to write this, 2x cubed plus 8x cubed times ln of x. In fact, you could go even a step further. We could factor out a 2x cubed. Notice that both terms have at least a 2 in it, right? This has an 8, but that an 8 has a 2 in it. And they both have an x cubed, so we could write it like this, 2x cubed times 1, okay, that would be this, plus 4 times ln of x. Okay, so you could write it really in any one of these three ways. So this first way, the second way, or the third way. I'm just going to put it in like this, 2x cubed plus 8x cubed times ln of x. Okay, now this one is similar. We have a product of two functions, so we're going to do the first function times the derivative of the second. By the way, there's another way that you could do this one. You could just distribute it ahead of time and take the derivative. In fact, let's do it both ways. Okay, so one way of doing this, taking the derivative, is to use the product rule. So we can take the derivative by doing the first function, 2x to the fifth, times the derivative of the second one, well, the derivative of that is 4x cubed, plus the second function, x to the fourth minus 3, times the derivative of the first one, which would be 10x to the fourth. And you could write this as your answer, and MyMathLab would mark it as correct as long as you're putting in the parentheses here correctly and everything. Or you could simplify this. Now notice this is going to simplify to be 8x to the 8th, right? 2 times 4 is 8, and x to the 5th times x cubed is x to the 8th. And then we have plus, well, let's distribute the 10x to the 4th. So 10x to the 4th times x to the 4th would be 10x to the 8th. And we have minus 30x to the 4th. Okay, in fact, you could combine these first two terms here, they're like terms. 8x to the eighth plus 10x to the eighth would be 18x to the eighth minus 30x to the fourth. So really, any one of these answers you could use in MyMathLab as being correct. But actually, another way of doing this one, though, since we can actually simplify this ahead of time, let's do this problem a little bit of a different way. Let's suppose we were to distribute the 2x to the fifth first and write this as 2x to the ninth minus 6x to the fifth. Right? So I'm just rewriting this original function here just by distributing the 2x to the fifth here. Now, what's the derivative of 2x to the ninth minus 6x to the fifth? Well, notice the derivative of 2x to the ninth is 18x to the eighth. Notice that's that. And the derivative of 6x to the fifth is 30x to the fourth. That's that. So one way of doing this problem would be to use the product rule, right? We could do this times the derivative of this plus this times the derivative of this. That's what we did right here. And then we simplified and we simplified down to here. Another way would be to distribute it ahead of time like this and then take the derivative. So go straight from here to taking the derivative, you get this. Okay, so our answer is 18x to the eighth minus 30x to the fourth. Now notice that worked on this one where you could simplify ahead of time. It wouldn't work on something like this because there's no way to simplify this ahead of time. You just have to go right in and use the product rule, right? So we don't have the option. We have to use the product rule there. On this one that we just did though, that one you could use the product rule or you could distribute it ahead of time before taking the derivative. Okay, now this one we have to use the product rule. We have x to the seventh times e to the x. The question is, what's dy dx? Right, so they're giving us y, so what's dy dx? What's the derivative? Okay, well, we take the derivative using the product rule. So we do the first function, x to the seventh, times the derivative of the second one. But the derivative of e to the x is just e to the x, plus the second function, times the derivative of the first, and that would be 7x to the sixth. So you could write your answer, again, in MyMathLab like this, and that'd be totally fine. Or you could actually simplify this. Notice we have two terms here. We have this term, and both of them have an e to the x in it. So we can factor out an e to the x. And in fact, they both also have at least an x to the sixth power. So we could actually factor out a e to the x times x to the sixth power. So let's write this out. X to the sixth times e to the x times, well, we would multiply it by x to get this. X to the sixth e to the x times x plus, and we multiply it by 7 to get this. Okay, but it's totally fine if you want to just leave your answer like this. Okay, but if you're checking your answer in MyMathLab or something like that, it might take this answer and simplify it by factoring out the e to the x and the x to the sixth power. But let's just write it like this. X to the seventh times e to the x plus e to the x times 7x to the sixth. Okay, now this one, they don't even actually tell you what the full formula is for the function. We have this function h of x that we're trying to find the derivative of. What's h prime of x? Where f of x is just some unspecified function. So f of x could be a polynomial, it could be e to the x, natural log of x, it could be really anything. So how would you take the derivative of this function h? Well, you do the first function, 9x to the fifth, times the derivative of the second. So we'd have 9x to the fifth times really f prime of x. Right, so notice that's what we have here, 9x to the fifth times f prime of x, plus the second function, so f of x, times the derivative of the first, so 45x to the fourth. So notice our answer here is C. Okay, that we use the product rule there to take the derivative. Okay, now this one is similar to one that we've done before. So we take the first function times the derivative of the second. The derivative of natural log of x is 1 over x. And by the way, you could then simplify that. So you'd have 2x to the fifth times 1 over x. That'd actually be 2x to the fourth. But then plus the second function, natural log of x, times the derivative of the first, right? 10x to the fourth. So I'll let you do that. And again, a very similar thing here. Find the derivative. We need to do d dx, right? The derivative of this. And again, we have a product of two functions. The first one is x to the eighth plus 6. And the second one is natural log of x. So you do this times the derivative of this plus this times the derivative of this. And you don't need to simplify your answer. You want to make sure you put in parentheses correctly, but you don't have to simplify your answer, although you can if you want to. Okay, now this one here, we don't have a product, we actually have a quotient. So we're going to apply the quotient rule. So f of x is a quotient of two simpler functions. We have x squared plus 1 divided by 7x minus 5. And we can't just do the derivative of the top divided by the derivative of the bottom. That's not the way to take the derivative of a quotient. So in other words, the answer is not just going to be 2x over 7, right? So this answer A here is not going to be correct. So remember, the derivative of a sum of two functions is the sum of the derivatives, and the derivative of a difference is the difference of the derivatives, but it doesn't work for products and quotients, right? We need to use the product rule and the quotient rule to take the derivative. So what is the quotient rule? Well, the quotient rule says the way you take the derivative of a quotient is to do low d high minus high d low. So by low, we mean the bottom part, 7x minus 5. D high, by D, we mean derivative. So what's the derivative of the top, the D high? That'd be 2x. So we're going to have 7x minus 5 times 2x. Right? Notice that's what we have here, 7x minus 5 times 2x, minus, and it's minus, not plus, minus high D low. So it's low D high minus high D low. So notice our answer right here, high D low. So we have low D high minus high D low all over low squared. Okay, so that's actually our answer B. So it's low D high minus high D low all over low squared. So low D high minus high D low all over low squared. And it's not high D low minus low D high, right? It's low D high minus high D low all over low squared. And again, by D, we mean derivatives. When we say D low, we mean the derivative of the bottom, or D high, we mean the derivative of the top. Okay, so what about this one here? How do we take the derivative? Well, we're going to do low. So let's write this as, let's get a fraction here first. But let's write this as low. So we're going to put 7x plus 2 and make sure to put it in parentheses. Low d high, so times 5. And you could put the 5 in parentheses if you want, or you don't have to. Low d high minus high. So by the way, the 5 is the derivative of 5x minus 3. Minus high, which is 5x minus 3, and make sure to put that in parentheses, d low times 7. So I could put times 7, or I could put the 7 in parentheses. Either way is fine. So there's low d high minus high d low all over low squared. Okay, now I could simplify this. In other words, I could distribute the 5 here and write this as 35x plus 10. And then minus, and I could distribute things here. We have 35x and we have a minus 21, and it's subtracting. So you could simplify that down. You could also simplify this. Now the way you'd have to simplify the bottom is to write it as 7x plus 2 times 7x plus 2 and FOIL it out. But let's just leave our answer like this. Okay, same thing here. Low d high minus high d low. So let's get our fraction. So low is x to the fourth. I'm sorry, x squared plus 4. D high, now the derivative of the top is 8x, okay, minus high d low. So let's get our parentheses here. High would be 4x squared plus 1 times d low. Now the d low is just 2x. Okay, all over low squared. X squared plus 4 squared. Okay, so notice we've done low d high minus high d low all over low squared. Okay, and again, you could simplify this, but I would just recommend just leaving it like this. Again, you could distribute the 8x across these and distribute the 2x across these and subtract. Make sure when you subtract both terms. You don't just subtract the first one and then add the second. But let's just leave it like this. Okay, now what about this? How do we take the derivative? Well, again, low d high minus high d low all over low squared. So let's check. Make sure we have low squared. Well, parts B, C, and D all have low squared in the bottom, right? X plus 12 squared. So we know it's not going to be A unless we simplifies and it comes down to this. But there's the low squared. Now let's do low D high. So x plus 12 times the derivative of x, which is 1. So we have x plus 12 times 1, right? So both of these are looking good so far, B and C. but then minus high d low. So minus x times, well, what's the derivative of x plus 12? It's 1. So notice it's this one. Notice it's supposed to be a minus here, not a plus. Okay, when you use the product rule, you end up having a plus. But for the quotient rule, there's a minus. Low d high minus high d low all over low squared. And by the way, if you were to do high d low minus low d high, you would get the negative of the correct answer. Your answer would be pretty close to being correct, but it would be off by a negative. So you have to do low d high minus high d low all over low squared. Okay, now similar here, low 6x squared. Oops, let me put it in parentheses here first. Let me actually get the form of the answer correct here. We're going to have something squared down here, right? So this is the form of the correct answer. In the denominator, we're going to have 6x squared plus 1 squared. Okay, in the numerator, we have low 6x squared plus 1 times d high. Now the derivative of e to the x is just e to the x minus high, which is e to the x, times d low, which would be 12x. Okay, so there's low d high minus high d low all over low squared. Okay, same thing here. And I'll let you work on this one, but we have low times d high, and derivative of 3x would be 3, minus high d low. The derivative of 24 plus ln of x, well, the derivative of 24 is 0. The derivative of natural log of x is 1 over x. And then that would be all over the low squared. So I'll let you do that. Okay, same thing here. Just like these ones we've done before, low d high minus high d low all over low squared. So just drilling into your brain how to do the quotient rule. Okay, again, same thing here. Low d high minus high d low all over low squared. Now, I think what they've done here is they simplified the numerator. Okay, so when they did low d high minus high d low all over low squared, they simplified things in the numerator. Okay, so let's actually do this one. We have f of x equals, and I always like to write the low squared part first. So 3x minus 2 squared down here. But then we have low d high. So 3x minus 2 times, well, what's the derivative of this? It's 2. Now, if you write it like this is actually not correct, right? This 2 needs to get multiplied by this whole thing. So this is not like 3x minus 4, right? This is in parentheses, right? That's why you need parentheses there. So this is really 6x minus 4. Okay, so there's low d high minus high 2x minus 7. And again, make sure to put in parentheses d low, right? And the derivative of the bottom is just 3. Okay, now when you work this out, when you distribute the 2, you're going to get 6x minus 4. When you distribute the 3 here, we're going to get 6x minus 21. Now remember, though, we're subtracting the whole thing. So we should not just put minus here, because we're actually subtracting the whole thing. So it's going to be a minus 6x. The minus also has to apply it to the minus 21. So it's really going to end up being a plus 21. Right? These two minuses are going to make it a plus 21. All over, and we'll just leave it as 3x minus 2 squared. So notice when we simplify this down, we're going to end up getting a 6x and a minus 6x. That's going to go away. And we have a negative 4 minus a negative 21. That's really negative 4 plus 21. So these are going to cancel out. We really have negative 4 plus 21 over 3x minus 2 squared. But negative 4 plus 21 is just 17. So our answer should be 17 over 3x minus 2 squared. And notice that's what we have here. 17 over 3x minus 2 squared. Notice this one was off by a minus. If you did high d low minus low d high, you would end up getting this answer, but that's wrong. It's low d high minus high d low all over low squared. Okay, again, do this one, low d high minus high d low all over low squared, and you're going to have to simplify the numerator, I think. Now here we're going to use the quotient rule to find g prime of 1, given that g of x is this. So what we're going to do first, before we can find g prime of 1, we need to find g prime of x. So we'll find g prime of x, and then we're going to plug in 1. Okay, so here's our problem. Here's g of x. Find g prime of 1. So that's really the slope of the tangent line of to the graph of this function at x equals 1. So g prime of x is going to be low, 4x plus 1, d high, so that'd be 6x. I'll put it in parentheses. You don't have to, though. Minus high, 3x squared, d low, which is just 4. Okay, so there's low d high minus high d low all over low squared. And to find g prime of 1, you could actually just plug in 1 for x right now, but let's simplify this a bit and then we'll plug in the 1. So distribute the 6x, we're going to get 24x squared plus 6x. And then minus, this is really just 12x squared. And still over 4x plus 1 squared. And now notice we have a 24x squared and a minus 12x squared, so that's just going to be 12x squared plus 6x over 4x plus 1 squared. So that's g prime of x. Now, what is g prime of 1? Well, we just need to plug in 1 right here. So this is g prime of x is this. So what's g prime of 1? Well, we need to plug in 1 for x. So we get 12 times 1 squared plus 6 times 1 all over 4 times 1 plus 1 squared. Okay, so 1 squared is just 1. So 12 times 1 is 12, and this is 6. So we really have 12 plus 6, which is 18 in the numerator. And the denominator, 4 times 1 is 4, plus 1 is 5. 5 squared is 25. So we have 18 over 25. Okay, now 18 over 25 is actually a decimal. I believe it's 0.72. But it's 18 over 25. Okay, I'm not sure if MyMathLab it does want you to simplify your answer, so it doesn't want you to just leave your answer like this right here. So it wants you to simplify your answer like this, but I'm not sure if it would accept either this or this. Let me actually try it. 0.72, see if that works. Okay, it gave it as correct, right? Or you could write it as 18 over 25. Now, just out of curiosity, you might wonder, what does g prime of 1 mean? Well, g of 1 is, well, let's see what it is. G of 1 is 0.6. Okay, so that's how high this point is. It's a height of 0.6, right? There's a height of 1, 2. It's a height of 0.6. What is the slope of the tangent line there? Notice this is actually a curve. It's not quite a straight line there. But what is the slope of the tangent line right there at 1? Okay, 1 comma 0.6. Okay, there's the point 1 comma 0.6. What is the slope? Well, the slope is a little less than 1. It's 0.72. Okay, or 18/25 is the slope there. In fact, by the way, we can even see what's g of 1 is 0.6. Right, so that's that point 1 comma 0.6. G prime of 1, Desmos will even do this. Notice it's 0.72. So Desmos is a good way to check your answer. Now, remember on exam 2 and the final exam that will be proctored exams, you won't be able to use Desmos, right? So you'll be able to use a regular calculator, but you won't be able to use an internet calculator or a cell phone. So you don't want to get too reliant on Desmos. Okay, now starting at 19, we're going to use the chain rule. So far, all these problems have dealt with the product rule and the quotient rule. What about the chain rule? Well, the chain rule tells us how we take the derivative of a composition of functions. So not when you're multiplying two functions or dividing two functions, but when you have one function inside of another function. And notice we have an inside function here, 9 minus 6x. But what's happening to that? It's being raised to the 11th power. So if we thought of the whole inside function as just one big x, notice our outside function is really x to the 11th. Our outside function is x to the 11th. So think of 9x minus 6 as just one big x. Our inside function is 9 minus 6x. So how do you take the derivative of a composition of functions where you have an inside function and outside function? Well, what you do is you take the derivative of the outside function. So what's the derivative of x to the 11th? Well, it's going to be 11x to the 10th. But instead of writing 11x to the 10th, we put 11 times the inside function to the 10th. Okay, so we have 11. So 11 times the inside function to the 10th. And then in the end, you have to multiply by the derivative of the inside function. And notice the derivative of the inside function here is -6. Okay, so again, we have this inside function 9 minus 6x and the outside function x to the 11th. So we take the derivative of the x to the 11th, we get 11x to the 10th, but we don't do 11 times x to the 10th. We apply it at the inside function. 11 times 9x minus 6 to the 10th. And then way out here on the end, we have to multiply by the derivative of the inside function. And we don't need to simplify our answer. Let's just leave it like that. Okay, we have a similar thing here. Differentiate the function or take the derivative of the function using one or more of the differentiation rules. So we're going to use the chain rule here. Okay, we have this raised to the 5th power. So how do we take the derivative of something to the 5th? Well, we do 5 times that something to the 4th. Okay, let's put the something in here. We have 9 plus 7x squared. 5 times the something to the 4th, but then times the derivative of the something. And the derivative of 9 plus 7x squared is really just 14x. Okay, so notice we have the derivative of the outside function, right? X to the 5th is 5x to the 4th, but we don't put 5x to the 4th. We put 5 times the inside function to the 4th, and then times the derivative of the inside function. Okay, that's how you do the chain rule. Okay, now here our inside function is 11x. Okay, 11x. Our outside function is e to the x, right? So you think of the whole inside function as just one big x. Our outside function is e to the x. So what's the derivative of e to the x? Well, it's just e to the x. But again, we're not going to put x, though. We're going to put our inside function. And then we're going to multiply by the derivative of the inside function, which is just 11. So the derivative of e to the 11x will be e to the 11x times the derivative of 11x, which is just 11. Okay, so anytime you have e to the something, the derivative is going to end up being e to the something, but then times the derivative of the something. Okay, same thing here. Now we have 8 times this. 8 is just a constant. So, by the way, you don't need to use the product rule here. In fact, let me make a point of this. Suppose we had a function like f of x equals 7 times natural log of x. Do I really need to use the product rule here? Okay, remember I thought that the derivative of a constant times a function was just the constant times the derivative. So in other words, it'd just be 7 times 1 over x. What happens if I applied the product rule, though? Well, the product rule, you can do the product rule. In fact, you do the first function, 7, times the derivative of the second one, which is 1 over x, plus the second function, natural log of x, times the derivative of the first. What's the derivative of 7, though? It's just 0. So all this just goes away, and it just ends up being the constant times the derivative of the function. Okay, so whenever you just have a constant times a function, you can just do the constant times the derivative of the function. I mean, you could do the product rule. You could do the first times the derivative of the second, which is right here, plus the second times the derivative of the first, but the derivative of that constant is always going to be 0. So that second part's always going to go away. And so you're just going to get 7 times 1 over x, or 7 over x. So what we're doing here with the product rule does not contradict what we did before. The derivative of a constant times a function just ends up being the constant times the derivative of the function. Okay, so same thing here. We have 8 times, well, what's the derivative of e to the negative 9x? Okay, so what's f prime of x? Well, again, you could think of this as a product and do the product rule, this times the derivative of this, plus this times the derivative of this, but the derivative of 8 is going to be 0. So all we're going to really need to do is 8 times the derivative of this. What's the derivative of e to the negative 9x? Well, the derivative of e to the something is just going to be e to the something, and then times the derivative of the something. And the derivative of the negative 9x would just be negative 9. So we could leave our answer like this, or we could combine the 8 times negative 9 and write it as negative 72 e to the negative 9x. Okay, what about this one? We have something to the negative 4th power, right? We have x to the 6 plus 8, that inside function, to the negative 4th power. So how do we take the derivative of something to the negative 4th? Well, it's going to be negative 4 times the something to the negative, well, would it be -3 or -5? It's -5, right? We have to lower that power by 1, right? So when we subtract 1 from -4, we actually get -5. So it's -4, now not x to the -5th, it's x to the 6th plus 8 to the -5th. And here we're almost done, right? We have -4 times the inside function, x to the 6 plus 8 to the -5th, but then we have to multiply by the derivative of the inside function, which is 6x to the 5th. Okay, so this is a chain rule. So the chain rule is a little tricky because you have to really understand about inside and outside function. Now let's do this one. We have something to the 4th power. So the derivative is going to be 4 times that something to the 3rd power. Okay, so let's put in parentheses here. The something is 9 plus ln of x. By the way, make sure you type the word ln. Don't type in. This is not capital I, lowercase n. This is lowercase l, lowercase n. Okay, 4 times 9 plus ln of x to the 3rd power times the derivative of the inside function. Now, the derivative of 9 plus ln of x is just 1 over x. Right? The derivative of 9 is 0. The derivative of natural log of x is 1 over x. Okay, what about this one? Calculate the derivative of the following function. So we're given a y, the square root of 2x plus 9, and we want to find dy dx. So how do we do this one? Okay, so here's our function, y equals the square root of 2x plus 9. We're going to write it as 2x plus 9 to the 1/2 power. That's what it means to take the square root of something. It's like you're raising it to the 1/2 power. So notice I haven't done any derivatives yet. I'm just rewriting the original function. Now let's do a derivative. So now let's find y prime, or dy dx. What is the derivative of this? Well, we have something to the 1/2 power. The derivative is going to be 1/2 times the something to the, well, what power? Well, remember, we have to lower this power by 1. If we lower 1/2 by 1, we get actually -1/2. Right? So we have 1/2 times the inside function to the -1/2. But then out here, remember to multiply by the derivative of the inside function, which is just 2. Okay, and by the way, you could write your answer like this, and that'd be fine. But actually, the 2 and the 1/2 will simplify. Okay, and we just get 2x plus 9 to the -1/2. And it's totally fine to write your answer like that. In fact, I will write it as 2x plus 9 to the -1/2. But you could write it as 1 over 2x plus 9 to the positive 1/2. And that's how you deal with a negative exponent, right? Do 1 over that thing to the positive 1/2. And that actually simplifies to be 1 over the square root of 2x plus 9. Okay, so any one of these ways of writing it would be correct. Now, it's good to know how to simplify this. I think MyMathLab will mark any one of these correct, but suppose you're doing a multiple choice problem. And let's suppose you found your answer to be this thing right here, but it didn't have that as one of the possible answers, but it did have this one, right? So you need to make sure you know how to simplify. Okay, so let's just write it as 2x plus 9 to the -1/2 power. Okay, and you do the exact same thing on this one. So you're going to do 1/2 times x squared plus 6 to the -1/2. Now your derivative out in the back is going to be 2x. So the 1/2 and the 2 is going to cancel, but you're still going to have an x. Okay, I'll let you do that one. Okay, same thing here. We have something to the -4. So we're going to get -4 times this something to the -5. And then you multiply by the derivative of the something. So multiply by the 8. Now notice none of those look quite like that. So what you need to do, in fact, I think what's going to happen is that -4 that comes out front is going to multiply by the 8 that you get out here, and you're going to get a -32. Okay, and it's going to be raised to the -5th power. So I think ultimately this is going to be the correct answer. Okay, so just make sure you do the simplification correctly. Okay, what about this one? We have something squared. How do we take the derivative of the something squared? Well, we do 2 times the something to the 1, right? So we have 2 times the something to the 1 power, and then times the derivative of the inside part, which would be 10t minus 4. So in fact, I think part B is the correct answer. We have 2 times this thing to the 1 power, then times the derivative of this out here. The derivative of 5t squared minus 4t is just 10t minus 4. So this is the correct answer. By the way, it's not plus here. When you do the chain rule here, we're doing the chain rule. We don't do 2 times this to the 1 plus this. It's times that, right? So it's answer B here. And by the way, that on that one, don't get freaked out because of the t, right? We're finding dy dt instead of dy dx, but all the derivative rules are the same. We're just doing a different variable. Okay, what about this one? Take the derivative. Well, the derivative of x, remember the derivative of a difference of two functions is the difference of the derivatives. So we can actually just take the derivative of x to the ninth and then subtract the derivative of this. Right, so we do 9x to the eighth minus, well, what's the derivative of 5 times e to the 4x? Well, it's going to be 5 times the derivative of e to the 4x, but the derivative of e to the 4x is just e to the 4x times 4. Okay, and I could write my answer like this, or another way of doing it would be to simplify. The 5 times 4 is really 20. So you could write this as 9x to the 8th minus 20 e to the 4x. Let's see if it'll accept this. Okay, now what's the derivative of e to the something? So again, we have an inside function, x squared plus 9x, and we have the outside function, e to that thing. Right, so we do the derivative of the outside function. We have e to the this, then times the derivative of the inside function. Right, so the derivative of e to the something, anytime you're doing the derivative of e to the something, your answer is going to be e to the something. And by the way, make sure you go down a level here with the x squared. Don't put plus 9x. We don't want that 9x as part of the exponent of the x here. So make sure you kind of click to the right and put 9x there. Whoops, I should put a plus as well. Plus 9x. And now out here, on the bottom level, put 2x plus 9. Okay, so I've seen students get the wrong answer by having this 9x up here be up with the exponent of the 2. Okay, but it's e to the x squared plus 9x and then times 2x plus 9. Okay, now what's the derivative of this? Well, again, the derivative of x is just 1. So notice we have this 1 on the end here. And the derivative of sum is the sum of the derivatives, right? So we can just do the derivative of this plus the derivative of this. The derivative of x is 1. What's the derivative of e to the 7x squared? Well, it'll be e to the 7x squared times 14x. Okay, so notice, isn't that what we have here? E to the 7x squared times 14x. Now, the 14x was written at the beginning, but that's fine. Now, what's wrong with this one? Well, this one doesn't have the e to the 7x squared. It just says e. In fact, none of these other ones have the e to the 7x squared. Okay, it's e to the 7x squared times 14x plus 1. Okay, what about this? Well, again, do we need to use the product rule? Do I need to do this times the derivative of this plus this times the derivative of this? Well, you could do the product rule. In fact, if you did the product rule, it'd be 13 times, well, what's the derivative of natural log of x? It's 1 over, oops, let me write it as 13 times 1 over x. Okay, you could put plus the second function, ln of x, times the derivative of the first function, right? But the derivative of 13 is 0, right? So ln of x times the second function times the derivative of the first, that's always going to be 0. So in fact, this is just going to go away, right? It's always going to go away. So whenever you have a constant times a function, you can just do the constant times the derivative of the function. You don't have to use the product rule. I mean, you could, but when you do the product rule, when you do the second function times the derivative of the first, that part will always have a derivative of 0. So we can write this as 13 times 1 over x, or 13 over x would be another way to write it. Okay, now again, what's the derivative of e to the something? Well, it's just e to the something, so negative 9x to the 6th. And then out here, times negative 54x to the 5th power. That's the derivative of negative 9x to the 6th would be negative 54x to the 5th. Okay, now this one involves natural log. Find dy dx for y equals this. So our inside function here is 5x cubed minus x squared. By the way, this is not a product rule type of problem. This does not mean natural log times this. This is natural log of this. Now, if this had been ln of x times this, you'd end up using the product rule. Okay, but here we're going to use the chain rule. We have an inside function, 5x cubed minus x squared, and we have an outside function, ln of x. Okay, you think of your whole inside function as just one big x. Your outside function is ln of x. Now, what's the derivative of the outside function? What's the derivative of natural log of x? Well, the derivative of natural log of x is 1 over x. Okay, but we're not going to put 1 over x. We're going to put 1 over this thing. Okay, so here's our function y. dy dx is going to be, well, the derivative of natural log of something is going to be 1 over the something. The derivative of natural log of x is 1 over x. So the derivative of natural log of something is going to be 1 over the something, but then times the derivative of the something, which would be 15x squared minus 2x. Okay, and you could leave your answer like this, or you could rewrite it. So this times this, you could rewrite this on the top of the fraction. We can rewrite it as 15x squared minus 2x over 5x cubed minus x squared. Okay, so here is our answer. So again, whenever you have an inside function and outside function, you always take the derivative of the outside function and you apply it at the inside function. So the derivative of natural log of x is 1 over x, but instead of putting 1 over x, we put 1 over the inside function. And then we multiply, always in the end, whenever you're using the chain rule, always in the end, you multiply by the derivative of the inside function. Okay, and again, you could write your answer like this as this times this, or you could rewrite it as this over this. Now, this is a multiple choice, and I think it wants your answer like this. Oh, and by the way, I don't see any of the answers looking like they're correct. So it looks like we should have a 15x squared minus 2x on the top. And none of these answers look right. So what's the issue? Well, I think the issue is here, they actually simplified things. Notice that there's an x in every single one of these terms. So we can actually factor out an x from the top and also factor out an x from the bottom. When we factor out the x from the top, we get 15x minus 2. When we factor out the x from the bottom, we get 5x squared minus x. Right? So you distribute the x here, it would become this. You distribute the x here, it would become this. And so these x's cancel. So what you end up with is 15x minus 2 over 5x squared minus x. So again, if this were not a multiple choice question, you could just put this as your answer or this as your answer. But notice neither of those appeared as one of the choices. So notice what we had to do is simplify. So we recognize all these terms have an x in them. We can factor out the x and then we cancel and we end up with this. So 15x minus 2 over 5x squared minus x. So that looks like it's the correct answer. Okay, so you got to be a little careful on those. Okay, what about this one? What's the derivative of natural log of this? Well, the derivative of natural log of that is going to be 1 over that, 2x squared minus 5x plus 8. And then way out here, you're going to multiply by the derivative of that function. So it would be 4x minus 5. And again, you could either put the 4x minus 5 out here like the way I've written it, or you could put it on the top of this fraction. Just write it as 4x minus 5 over this. Okay, so remember the derivative of natural log of something is going to be 1 over the something, but then times the derivative of the something. Okay, that's really what the chain rule says. Okay, same thing here. The derivative of natural log of something is 1 over the something. So 1 over 4x squared minus 5x plus 7. And then times the derivative of the something, which would be 8x minus 5. And again, you could put that 8x minus 5 on the top of this fraction, right, as 8x minus 5 over this. Okay, same thing here. So I'll let you do this one. Derivative of natural log of this is going to be 1 over this times the derivative of that. Okay, same thing here. Right, all these problems are similar. I'm just giving you a bunch of practice. I'm kind of drilling into your mind here. How do you take the derivative of natural log of something? Well, it's 1 over the something times the derivative of the something. By the way, one other thing I want to mention here. Why don't we use the chain rule for something like this? Natural log of x. Didn't I say the derivative of natural log of something is just 1 over the something times the derivative of the something? If we try to apply the chain rule here, what would happen? Well, we're going to do 1 over the something, but then we're going to multiply by the derivative of the something. But what's the derivative of x? It's just 1. Right? So when we don't have really an inside function, the inside function is just x, Notice the derivative of natural log of x is just 1 over x, or it's 1 over x times 1, right, if we wanted to use the chain rule. But that times 1 doesn't change anything, right? The derivative of natural log of x is just 1 over x. But really, the derivative of natural log of anything is 1 over that anything. But when you do an anything, you have to remember to multiply by the derivative of the anything. If the anything is just the x, the derivative will be 1. Okay, now same thing here. Now here we have a coefficient, we have a 4. So, but the way we take the derivative of this is going to be 4 times the derivative of this. So we could write it as 4 times, well, let's do 1 over 9 plus 5x squared. And now here we'll multiply by the derivative of 9 plus 5x squared, which is really just 10x. Now we could leave our answer like this, or we could combine the 4 and the 10x to become a 40x, and we could put that on the top of this fraction. So actually this would all simplify down to 40x over 9 plus 5x squared. Okay, but it'll accept this as the correct answer. And again, why did we not need to apply the product rule here? We have a product of two functions. Why did I not need to do 4 times the derivative of this plus this times the derivative of 4? Well, the derivative of 4 is 0. So that second part will go away. You just do the first function times the derivative of the second. If you try to do plus the second times the derivative of the first, well, that will go away. That'll be 0 because the derivative of 4 is 0. Okay, almost done. Now, what's the derivative of ln of 9x? Well, it's going to be 1 over 9x, but then times 9. And actually, amazingly, that simplifies to just be 1 over x. Okay, so you could, derivative of natural log of 9x is actually also just 1 over x, because it's 1 over 9x, but then times the derivative of 9x, which is 9. And by the way, one other reason why that works is what's ln of 9x? Isn't that the same thing as ln of 9 plus ln of x? And the derivative of ln of 9 would be 0, right? Because it's just a constant. And the derivative of ln of x is 1 over x. So the derivative of ln of 9x ends up really just being 1 over x, right? It's 1 over 9x times 9, but the 9's actually cancel. Or you could have simplified this ahead of time, written as ln of 9 plus ln of x, and taken the derivative of those. Okay, now we also have plus, well, the derivative of 7x is just 7. Okay, now what about this one? It looks like we're going to need to use the product rule here and the chain rule. So we have find g prime of x if g of x is 2x times e to the 7x. Okay, so notice we can think of this as a product of two functions. Let's think of it as the product of 2x and e to the 7x. And the reason I can't just do the, this times the root of this, well, is because this is not a constant here. Okay, this is 2x. Okay, so how do we take the derivative of this? Well, we have to use the product rule. So we do g prime of x will be the first function, 2x, times the derivative of the second. Well, what's the derivative of e to the 7x? Well, it's going to be e to the 7x times 7. Okay, plus, and remember it's plus for the product rule. We have the first function times the derivative of the second, plus the second function, e to the 7x, times the derivative of the first. And what's the derivative of 2x? Is just 2. Okay, now you could write this as your answer. Just type it in all in like this, and that'd be fine. You could combine the 2 and the 7 becomes a 14. So you could write this as 14x times e to the 7x. And here we could also write the 2 out front, write it as 2e to the 7x. In fact, so I'm going to use this as our answer here. In fact, you could even go one step further and factor out an e to the 7x. In fact, you could factor out a 2 as well, a 2e to the 7x. And you could write this as, well, this is going to be plus 1. 2e to the 7x times 1, that'll be this. And 2e to the 7x times 7x would give you this. Okay, so if you wanted to really simplify it, this would be your answer. So if it maybe gave you this as a multiple choice answer, maybe it wouldn't show you this as a possible answer or this one, but maybe it'd show you this. So it's good to know how to simplify. But let's write it as this, 14x e to the 7x plus 2e to the 7x. All right, and the last one, find the derivative of y with respect to x. So in other words, what's dy dx? And we're given this function right here. Okay, what is the derivative here? And I think you're probably going to need to simplify your answer to get it down to one of these. So we have y equals x to the 6th times natural log of x minus 1/3 x cubed. Okay, so what is y prime or dy dx? Well, for this one, we need to use the product rule. Right? We have a product of two functions, and it's not just a constant out here, it's x to the 6th. We have a product of two functions. We need to use the product rule. So we do the first function, x to the 6th, times the derivative of the second one. Derivative of natural log of x is 1/x, plus the second function, natural log of x, times the derivative of the first. And the derivative of x to the 6th is 6x to the 5th. Okay, so all of this right here, all this, that's the derivative of this part. Okay, now what about the other part? We have minus 1/3 e to the x cubed. Well, we multiply the 3 out front. Bring the 3 out front. 3 times 1/3, though, is just 1. So we don't even have to write the 1. And then you lower that power by 1. Wouldn't this derivative just be x squared? Okay, we have minus. Derivative of 1/3 x cubed is just x squared. Now, again, this is probably not going to appear as one of the answers. In fact, I don't think this appears as one of the answers for the multiple choice question. But notice this simplifies to be x to the 5th plus natural log of x times 6x to the 5th minus x squared. And notice that answer is actually equivalent to this. So they've written it a little differently. They wrote the minus x squared here instead of on the end. And they also wrote the 6x to the 5th times ln of x instead of ln of x times 6x to the 5th. So in other words, they rewrote this as x to the 5th, and then they have this minus x squared, so they brought it out front. And then we have plus this term, but they rewrote this term with the 6x to the 5th first. Okay, so this is the answer that they have there. All right, and that's all the homework. And so really, this homework was all about these derivative rules. We had the product rule, we had the quotient rule, and we had the chain rule. I think of the three, the chain rule is probably the trickiest of them. But I think we did enough examples that hopefully you get the feel for this, how to take a derivative.